All right, now let's talk more about formulas. So a formula or mathematical model has to do more with equations. So now we're bringing in those equal signs here, but we still work with them very similar often to expressions where we have a lot of simplifying and values to plug in and so on. An equation is formed when an equal sign is placed between two algebraic expressions. A formula is an equation that uses variables to express relationship between two and more quantities. So a formula is just like an equation, it just that usually has more real world meaning. Our equations do too, but a formula usually is very specific and shows a really specific relationship between multiple variables. The process of finding formulas to describe real world phenomena is called mathematical modeling. And such formulas together with the meaning assigned to the variables are called mathematical models. So each of the variables in a formula has specific meaning, right? It's not just a variable that's holding in place, although it is, but it has a specific meaning. Usually we use like L for length or T for time, so something specific. And we say that these formulas model or describe the relationships among the variables. So here we have an example from your text, and I just copied it into the handout to make it a little bit easier to talk about. It says, the bar graph in the figure shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. So moderately active lifestyle means a lifestyle that includes physical activity equivalent to walking 1.5 to 3 miles per day at 3 to 4 miles per hour. In addition to light physical activity associated with typical day-to-day life. Okay, so someone who does moderate activity, so maybe someone who walks daily and does a few mile walk daily or something equivalent, right? So maybe you're not walking, but you're doing some sort of exercise. Okay, so here's our information. And for instance, you can see men are in yellow and women are in red. So for those who are around 4 to 8 years old, each group needs around 1,500 calories a day. When you get to 9 to 13 years old, then it starts to split. So women need a little bit less, around 1,800, and men need a little bit more, around 2,000, and so on. So you can see how it changes. Now, here's our bar graph, but there is a specific mathematical model used as well. So the mathematical model W equals negative 66x squared plus 526x plus 1030 describes the number of calories needed per day by women in age group X with moderately active lifestyle. So we're focusing on women here, hence the W. According to the model, how many calories per day are needed by women between the ages of 19 and 20 inclusive? Sorry, let's just say 30. Sorry, guys. Thought that looked wrong. So between 19 and 30 inclusive with this lifestyle. Does this underestimate or overestimate the numbers shown by the graph and by how much? So that 19 to 30 group is right here. Okay. So if we look, this is group 4. So in this case, our X value is 4 here. So if you look at the model, it says age group X. So our group is group 4. So we're going to go ahead and take that formula, and I'm going to replace my X with 4. Now, I'm still using evaluating. So I know I have an equal sign here because it's a formula, but we're still evaluating. I plugged a value in. I'm going to use that order of operations to simplify. So I'm going to go ahead and do my exponent first here, which is 16. And then I'm going to go ahead and do my multiplication next. I don't see any division. And I get here, negative 1,056. So I have the work already done off to the side. I get 2,104 and then plus that 1,030. So just using your calculator there to get those values. And then finally, I'm going to go ahead, I'm going to add and subtract left to right. So I'm going to go ahead and do these values first and then add the 1030. When I do everything together, I'm going to get 2,078. So our formula estimates that a woman in group 4 needs about 2,078 calories per day. So that's based on the model. And let's look at our graph up here. So if I go back to my graph, then we see the value for women. So women was red, where our age group is right here. It's 2,100. So that's actually a really close value, right? So our model looks pretty good for that bar graph. They match together pretty well here. So technically, it slightly underestimates the number shown, right? Because 2,078 is less than 2,100. But they're very, very close here, right? So we have so the formula, I would say slightly underestimates the value. And so if I take that 2,100 and I subtract that 2,078, I can go ahead and see how much it underestimates it by. And it's only by 22 calories per day.